Can you go over the concentration, equilibrium, constant expression for this reaction?
Just this guy?
Mm-hmm.
Just that?
So, but it has like.
Yep. So same kind of thing, but remember, this only works for gases and aqueuses. If anybody is a liquid or solid, we don't use them. Less work for us. I love them.
Okay. So the C is HF.
So this is if the guy was like this. So this is my equation, my reaction. So the products go on top, reactants go on bottom. And if he's aqueous, I keep him. If he's solid, I kill him. I don't use him. I love it. If he's a gas, I keep him. If he is a liquid, I kill him.
Okay.
Yeah.
And then to calculate the value of the equilibrium Kp for this reaction, was that the one where it's the products on top of?
Yep, same kind of thing. So you're just setting this up, and so then if you have like subscripts, then you just put the numbers in. I can go through that if you want.
Yeah. So for example, it says the compound Br squared is 95 ATM. So if it's 4 HBr, we'll just multiply the 95 by the 4. So for like this one here, the Br is at 95 ATM. We'll just multiply that by the 4.
Well, this is bromine gas and heat right there.
Oh, sure. You can. So yeah, multiply that one by 4.
So yeah, so we have the HPR and O. So you just set this up like we were going to before. And then we have oxygen. Who's going to go on bottom?
It's going to be 2 Br subscript 2 plus 2H2O.
Oh, so then there was a 2 up here? Is that what you were saying? There were 2, okay.
Yeah.
And then H2O you said?
Yeah. To the side. Yeah, like that.
So those are their coefficients. Cool. So then you just put the numbers here. What's HBr?
HBr is 44.9.
Is that the answer you gave them?
Who's
Yeah.
oxygen gas?
63.2 or 60.6.
What you said?
63.6.
Okay, 60.
Yeah.
0.6. And who's bromine, liquid or gas?
Whoa. It's 95.0.
What?
And then who's water?
H2O is 71.0.
Do you want this?
You don't want?
I do, but did you get me?
So then you just do the
Oh.
44.9
Yeah.
to the fourth.
Fine.
Times by that guy. Divided by this whole thing. The 95 to the second.
Okay.
Those guys and those guys times. Does that make sense? What we did?
Yeah. We're multiplying them, right? We don't add them together.
Add, or yeah, multiply.
Okay.
Yep.
9 squared times.
Because I'm so weird.
What is that?
So
It's kind of the same, but I don't quite understand.
So what happens with the catalyst? What does the catalyst do?
she just made that up herself
Like
and I was her.
You're slapping it in the face.
What happens to the rate? It increases.
Okay.
It lowers the activation energy. So the only difference between these two graphs is that this one's going to have a lower
I
activation
need you
energy.
to crack my back later if you're ever.
Okay.
Sweet. That works.
Is this the sun sign?
Why are you plusing that?
Yeah.
Oh, times.
Sorry, it's
It's
only
supposed to be
4
on top,
at a time.
right?
Yeah, that's why you would.
Yeah, I have a ton of them on me too.
Oh.
Did I have that right?
Where are you going after this?
Probably home. To work on that.
Look good.
Okay, thank you.
Question, this may sound really dumb, but when I sent to the calculator, I
Did
did
you
it just like that,
perform
it
in
came up a huge
the?
number.
Are you like
It's
in a
44.9.
Canadian thing last semester?
No.
Fall semester?
Mm-hmm.
You're not?
No.
63.6
Do I just have that face?
No, you have
divided by
no, you look
95 squared.
like a guy that was in.
Apparently, I have a
There you go.
doppelganger running around.
You do?
You are dividing by
No,
him and
probably.
times by him.
I've been here
You have
5
to put parentheses
semesters so
around that
far,
area
and
and
I've
divide.
had
Gotcha.
3 or 4 separate people just text me like, "Hey, are you at the crossroads right now?"
I've never
Okay.
seen
I'm
him.
like, "No," and they're like,
Good.
"Okay, good, because I yelled at you and you didn't listen." I'm like, "What?" Like, there's a person who looks exactly like you. So
Yeah, he's in the Canadian thing. If that's what it is.
So are they both under the rank?
I'd like to meet him.
He's funny.
Well, no, only since
It's like, so it's you. We
They're
finally
both
meet.
under the rank.
Oh, they both are?
Yeah.
How do you know that?
It's just, you're just adding a catalyst. The only thing that changes with the catalyzed reaction is that the activation energy is lower. So you got the products at the same level, right? Because remember, the only difference between these, the products are the same. The only difference between the graphs is that the activation energy is different.
Okay, so you just have to make.
So the products are on the same level on both sides, reactants on the same level on both sides. Mhm.
So really, you're only.
Well, she
Yeah,
said.
seeing that guy, yep, making sure they're both under the rank.
Okay.
Yeah.
So, in this one, in the products, there's only one aqueous.
Sweet. Use
So,
one of them.
and then the rest are aqueous. Is that right?
Okay, yep. That guy did 6. Okay, yeah. Great.
Sweet.
I don't have
Oh
to.
my gosh.
I don't have to combine them.
No. And so then he's a liquid. And then, yeah, if you tap those big boys in there, right, then go for it.
Okay. I just feel like it shouldn't be this easy.
Then you plug in numbers.
It tricks me every time.
Oh, these lovely things. Okay, let's talk this through. I like to play leapfrog with these. And that's what, I don't know if you guys have gotten into that in class yet. I think she's gonna play leapfrog with you. So, imagine we're about to remove
Question,
this guy.
if we're just going to the 2 significant digits,
So
And I need that as an answer, where should we put
from
that?
flasks contain a mixture of them at
From
equilibrium.
here, 6.
So what is the rate of the reverse reaction before any of that guy is removed? They're at equilibrium right now,
Oh.
so is it
Well,
going to
it
be
could also
greater,
be rounded
equal
up.
than, or less than the forward reaction?
To
It's at
one.
equilibrium right now.
Equal.
Equal.
So you could do is 1.0.
So then on this one, what is the rate of the reverse reaction just after he's been removed in the flask? So I'm guessing this guy plus him equals this and that.
Yeah, I was wondering, because I thought you'd have a 0 on there.
So he's on this
Alex.
side, which would mean this side, if I
I remember
remove
that one.
him,
Yeah,
gets
okay.
heavier or lighter.
Lighter.
So he goes up, and so I have to hit my top hand. So that means the forward reaction is going to be faster than the reverse reaction. Because I just took away some of the products, that means these guys are going to go that way to
Okay.
equal back out.
Okay.
So it'll be greater than?
The reverse
So this one
reaction.
is basically
So
what
less.
you're doing. We just
Yes,
do
because the
this.
forward
but
one's
plug
going
in
to go
numbers.
faster.
You're on a different
Oh,
one.
okay.
Well,
And so then what's the rate of the
equation's
reverse
different,
reaction
but the
after it has
Oh,
reached
you're on the
equilibrium
same-
again?
principle using only aqueous
Less.
solutions.
If it,
That'd be right.
in relation to the forward reaction.
Greater.
If it reached equilibrium again.
Oh, equal.
Have you done this one? The
And then this
question?
one is usually some but less than that.
Oh,
That answer is usually that one.
Okay. Is that the same?
Does that make sense?
Maybe.
Kind of. I'm trying to get the whole like.
So these guys are all in a flask and they're all at equilibrium. So it's him plus him equals him plus him. And they're all at
Do you
equilibrium.
think it wants me
Before I
to just do
touch it,
the
before I
same
remove
side
anything,
or
the
put
rate
it into
they're
the
equal.
same notation?
Once I remove some of the product, he got lighter, which means I need to use up some of
Have
these
they all been
heavy
scientific notation
reactants.
so far?
to make more products.
I only did one.
So that meant what my hand just did, my
Well,
forward
actually,
reaction
two
was
of them
faster.
were.
Two
yeah.
sig figs.
Okay.
So I can
So
go
I
in
think
down.
it would be
It can
5.3
give you-
or 5.4.
Get back to equilibrium.
Times 10 to
That's
the
why
power of 1,
the
or negative
forward
1.
reaction
0.54
is greater
over
than,
two
so the reverse
sig
reaction is
figs.
less than the forward
Yeah,
reaction.
you're true.
Okay.
That's right.
And then once it reaches equilibrium again, they're equal again. And then how much less is that? Somewhat less than that.
Okay. Perfect.
So see if you can have fun. So
Okay.
if you remove it or if you add it. So if I added more, so you have to figure out which side is he. Well then if I added more, he became heavier, which means I would go this way.
Okay.
So just you leapfrog in the testing center.
Okay.
I just have a quick question about sig figs right